Hello guys, welcome to a new video, and in this video we are going to go over this for the CCNP security exam for the SIMOS exam, and we are going to go over configuring IKEv2 for the IPsec implementation, and we are only going to be doing IPv4. Okay, so I'm going to go over everything we are going to be configuring, and the first part that we are going to reconfigure. It is the IKEv2 proposal. And in that IKEv2 proposal, we are going to propose to the router that we are going to be connecting to how we are going to encrypt to provide data confidentiality. So we are going to do 3DES and then data integrity, which is going to be ND5, and then the Diffie-Hellman group, which is going to be Diffie-Hellman group 2. And then after that proposal is configured, we are going to be configuring the IKEv2 policy. And in the IKEv2 policy, what we're going to do is we're just going to attach the proposal. Whenever we configure that proposal in the IKEv2, the proposal needs to go inside the IKEv2 policy. So let's go ahead and put this over here. And then we are going to go ahead and grab it and move it if you're able to do it. No, not like that. It's a little bit hard to grab it in this website. Just give me one moment. There we go. Why is it doing it like that? That's not what I want. Where's the little hand? Not like that either. There we go. So whenever we configure that proposal in the IKEv2 policy, we are going to include that proposal in the IKEv2 policy. Then after that, we are going to move on and um, we are going to configure the IKEv2 keyring. And in that keyring, we are going to add the keys that we're going to use to authenticate in that tunnel. And inside that keyring, we are also going to add that pair and then that local and remote key, like I said before. And then after that is configured, we are going to be configuring the IKEv2 profile. And inside that IKEv2 profile, we are going to have that IKEv2 keyring. So let's go ahead and move this over here because we need to add that IKEv2 keyring to the IKEv2 profile. And in the IKEv2 profile, we're also going to tell the router how we are going to authenticate, which is going to be using a pre-share key. We're going to attach a keyring, and we are going to provide those remote identities and those local identities as well. Then we're going to move on and configure the IPsec profile. And inside that IPsec profile, what we have to do, we're going to create that IPsec profile. Or actually, before we do that, we need to configure the IPsec transform set before we do that IPsec profile. And inside that transfer set, what we're going to do is um, we are just going to tell how we are going to um, encrypt also for data confidentiality, and we also need to provide data integrity. So we're going to be using SHA with HMAC for that. And then after we do that transform set, we are going to configure the IPsec profile. And inside that IPsec profile, we need to add the IPsec transform set and also the IKEv2 profile, which has the IKEv2 keyring inside. So let's go ahead and point to the IPsec profile, or the IPsec transform set needs to be inside the IPsec profile, and also the see if I can grab it. Okay, oops. So it is down here. That's what it is. So let's go ahead and move it right here, and let's point to the IPsec profile. There we go. And then we're going to configure the tunnel, and inside the tunnel, we need to add that IPsec profile. So let's go ahead and do that. All right. Let's go ahead and turn it around and point to the tunnel. There we go. That's how the configuration is going to be. So let's go ahead and see my topology. There's my topology that I have. I have configured all the IP addresses and all the interfaces are up and running. So let's go ahead and start with that configuration. Okay. So like I said, we are going to start with the IKEv2 proposal and then the IKEv2 policy. Let's go ahead and start that. Enable config T. So let's go ahead and do a crypto IKEv2 proposal, and we are just going to call it proposal 1. And as you can see right here, the IKEv2 proposal must either have a set of an encryption algorithm other than AES and all that, and therefore have it configured. So let's go ahead and do the encryption method, which is going to be 3des, and then we need to provide integrity, and the integrity, which means the SHA or the hashing algorithm, and we're going to be using for that MD5. And then the OVM group number is going to be group number 2, exit, and then after that, we are going to be configuring the IKEv2 policy, and then we need to attach that IKEv2 proposal in the IKEv2 policy. Okay, so let's go ahead and do that. You do a crypto IKEv2 policy, and let's just call it PAL1. And inside here, what we need to do, let's just do a match V. We're going to match the V the FVRF to any, right? And then, like I said before, once we do that, what we need to do is, um, or actually, we need to, let's go ahead and do, let's just not do that. Let's go ahead and do the match address, and the local address is going to be 20.1.1.1. Enter, and that's it for that. So you need to put your local address from where we are going to be using to connect to router 2, right? So that is good. And then, like I said, we need to attach that IKEv2 proposal. So let's go ahead and do that. So we are just going to do a proposal and tell that we're going to be using that proposal that we just configured, which is pro-1 paste. Okay, so after that is done, what we need to do, let's go ahead and see my drawing. We need to go ahead and configure the IKEv2 keyring. So let's go ahead and do that. So you're going to do a crypto IKEv2 keyring, and we just go ahead and configure a keyring name. Let's just go ahead and call it keyring or IKEv2 keyring. And inside this keyring, we are going to be configuring for peer 2 and peer 2, or actually just do peer R2, which is the name of the next router. And over here, you need to put the address of R2, which is 20.1.1.2. And then we need to say that we're going to be authenticating using pre-shared key with the local of key, or actually use the R1 key, which is going to be the local or local key. And then for the remote key, it's going to be R2 key. And this needs to match whenever we configure R2. It needs to say that the remote is going to be using R1 and the local is going to be R2 key. Okay, exit. We are done configuring the key ring. So after that is done, what we have left, the key ring, we need to configure the IKEv2 profile. So let's go ahead and do that part. You do a crypto IKEv2 profile, and let's just name this IKEv2 profile. So inside here, what we need to say is, first of all, we need to do the authentication. For the local, it's going to be pre-shared key authentication. For authentication for the remote user, is also going to be using a pre-shared key. Then we need to do a keyring local, and we need to attach that keyring, which is called IKev2 keyring. Paste it right here. Then we need to create some identities. So the first one is the match identity of the remote match identity of the remote, which is going to have an address of 20.1.1.2. And then we need to do the local identity, which is an address of 20.1.1.1 for the local side, because we are configuring R1. All right, that is good. So we are done with that part. So after that is done, let's go ahead and configure. Let's see what we have next. So we did the IKev2 keyring and the IKev2 profile, and then we attached the IKev2 keyring, so that's done. Let's go ahead and configure the IPsec transform set. Crypto IPsec transform set. We are going to call it this T set, and we're going to have data confidentiality with AES 256, and then ESP for data integrity, SHA using HMAC. And all of this needs to match on our router too. All right, we are done with that. Now we need to go ahead and create. What is it that we need to create? Transform set is done. We need to go ahead and create that IPsec profile. And all we did when we do that, we do a crypto IPsec profile, and we're going to call this IPsec profile. And we just need to set the transform set, which we call T set, and then we need to set the IKev2 profile to whatever we name that IKev2 profile, which is IKev2 profile. There we go. So that is done. And after that is done and completed, what we need to do is let's go ahead and create that tunnel, interface tunnel, 0. So from there, what we need to do is we need to add the tunnel source, which is going to be gigabit 00, right? Yep, that is correct. And then we need to go ahead and create the tunnel destination, which is 20.1.1.2. Then we need to do the tunnel mode, which is IPsec with IPv4. There you go. Right, it is the complete command is like this: tunnel mode IPsec using IPv4, and then we need to configure the IP address for this, which is going to be 50.1.1.1, 255.255.255.0, and then we need to add that IPsec profile to it. So tunnel protection IPsec profile, and then we need to add that IPsec profile that we just created, which is IPsec profile. Done. There it is. So after that is done, we need to go ahead and we are going to be using EIGRP. So let's do a router, EIGRP 18. Let's do no outer summary. We need to add a couple networks. For router 1, we need to add this network that we have over here, 192. That's 168.1.0, and we also need to add the network of the tunnel, so 50.1.1.0. And actually for this one is to be like this. All right, so there you go. So we are done with the configuration of R1. If you want to do some, you can do some show commands, but it is better if you do it after R2 is configured. So let's go ahead and configure R2. So for R2, the first thing that we need to create is a crypto IKev2, and it's going to be the proposal. And the proposal is going to be IKE. We're just going to call it Pro 1. And we are going to propose the encryption. This needs to match with whatever we configure on the other side. So make sure that it matches integrity MD5. And then what is it? The match or for the group is 2. All right, and then we need to do a crypto IKev2 policy. And we're going to call this part 1. And what we need to do from here, we need to add that proposal that we just created, which is Pro 1. And we need to match the local address, the address, local 20.1.1.2. All right. So after that was done, we are supposed to go ahead and create the crypto IKev2 Keyring, and we're going to call this IKev2 Keyring. Inside this keyring, we are going to mention the peer, which is R1, authentication, or is it authentication? Let's see. The pre-share key for the local is going to be R2 key, and the pre-share key for the remote is going to be R1 key, and then the address for that is going to be 20.1.1.1. Right, I did that, yeah, R1, so that's done. After that is done, we need to go ahead and configure crypto IKev2 profile. We're going to call it IKev2 profile. And inside this IKev2 profile, we need to tell it how we're going to authenticate, which is using for the local pre-share key, and authentication for the remote is also pre-share key. Then we need to go ahead and attach that keyring, the local keyring, which we call IKev2 keyring. Paste. Then we're going to have to create the match identity for the remote, which is 20.1.1.1. Actually, we need to put address. And then the identity for the local is going to be 20.1.1.2. Good. Moving on. So now, after that is configured, we need to go and configure the crypto IPsec transform set. This one also needs to match. So ESP. Actually, we need to name it first. Tset. ESP. AES. I believe it was AES. Let's just go ahead and verify over here to show crypto IPsec transform set. Yep, so AES with HMAC. So 256. And then for data integrity, shot with HMAC. Exit. Then let's go ahead and do a crypto IPsec profile. And we're going to name it IPsec profile. And in here we need to set the transform set, which we name Tset. And then we need to set the IKev2 profile, which we call IKev2 profile. All right. After that is done, let's go ahead and create a tunnel. 0 source gigabit 00 or tunnel source, and then tunnel destination 20.1.1.2. All right. And then we do, after that is done, we need to do the tunnel mode IPsec with IPv4. Then we do the IP address 50.1.1.2. And then we just add the tunnel protection, which is the IPsec profile. And we need to attach that IPsec profile that we created. Simple enough, right? Then after that, we need to do a router EIGRP. This one needs to match. I believe it was 18. Let me verify that. Show IP route, show IP EIGRP 18. 18 what? Interfaces. So there we go. Good. It is 18. No auto summary. The first network that I want to add needs to be this network over here, 10.10.10.0, 255. Then the next network is the tunnel network, 50.1.1.0, and that should create a EIGRP, or it should, 50.1.1.0. So let's just do show run section EIGRP 50.1.1.0 and 192 network, EIGRP 18, EIGRP 18, and show IP interface tunnel 0. This tunnel is up, line protocol is down. Show IP interface brief. Well, let's just show run. We're having some issues here. So show run, let's just do section tunnel. So we configure source, destination. Okay, destination is wrong. That's why. Let's just do config T, tunnel. Why didn't you guys tell me? Interface tunnel 0. Let's just shut it down. And then let's do no to this destination. And then do tunnel destination 20.1.1.1. No shutdown. And that should bring up the EIGRP. There we go. Neighbor relationship. Good. So if we do show IP EIGRP neighbor, you can see that we have a neighbors with a tunnel. So cool. So now if you want to see the IKev2 and all that good stuff, you can do a crypto IKev2 SA maybe. Show crypto IKev2 SA. We don't have any. Let's just do a show crypto IPsec SA. And this is, so you can see we are sending, we have encapsulated 15 packets, and we have decapsulated 15 packets. So that's mean that it is working. You can see the local identity. It's this and that. The current peer is 20.1.1.2, which is correct. It's a port 500 because we are now using NAT. We're now using network address translation. Local endpoint 20.1.1.1, good. remote encryption endpoint 20.1.1.2. So it looks like it is working. What if we do a ping? Let's just go ahead and do ping 10.10.10.1 with the source of 192.168.1.1, and we want to repeat it 100 times. Okay, and now let's do show IPsec SA. And you can see that since we sent 100 packets, 100 were encapsulated and 100 were decapsulated, but it incremented because we are sending EIGRP packets and they are being encrypted. And if you want to see that encryption going on, you can do a debug crypto engine packet, and that's going to show you all the encryption happening. There we go. So as you can see, it is working. It is encrypting everything. We have some errors right now that we can take a look at later. The CEF switch failed with less but it is encrypting everything you're sending. And if you want to turn it off, all, all, there we go. That turns off the encryption or the debugging on all. Good. So as you can see, we have successfully configured IKev2. And in this video, we went over and configured the IKev2 proposal where we put that encryption, 3DES, integrity, MD5, um, and then after that, we created the policy, and inside the policy, we attached that IKev2 proposal. Then we configure the IKev2 keyring, where we put that key that we're using to authenticate. After that was done, what happened was we created the IKev2 profile, and we did all that good stuff, and then we attached that keyring. Then we created the IPsec transfer set, then the IPsec profile. Inside that IPsec profile, we attached the IPsec transfer set and the IKev2 profile, and then we created a tunnel, and inside that tunnel, we created the IPsec profile. So this is set for this video. Thank you guys for watching. I hope you guys enjoyed. I hope you guys learned. And if you guys did learn something, go ahead and subscribe to my channel. Also, why don't you just go ahead and follow me on Twitter at CCNA Daily Tips. Thank you guys for watching. I'll see you in the next one, guys, and I love you very, very much. Bye bye.